All right, how's everybody doing? Good? Conference good so far? Taylor and Ian and everyone else has done a great job putting this together. Thank you guys. Pleasure to be here. Real quick, I am aware that my zipper is broken on my pants. So make your tweets and get your jokes out of the way and whatnot. I'm well aware that my fly appears to be down. However, it's not down, it's broken. So get your jokes out of the way, especially you. Today I'm going to talk about doing things later, procrastinating your web applications, making things happen out of the way of the user. First of all, who am I? My name is Zack Kitzmiller. I am currently employed at SeatGeek, an engineer there. I was formerly the lead engineer at Forest. Also, I run Streakly, which is a Seinfeldian calendar for, it's like a to-do list, but things that you do want to do every day, so it doesn't change much. Read a book, push-ups, whatever it is. Done some open source things, Sixpack. I'm about to launch on Wednesday, which is a language agnostic A/B testing framework. Incredibly cool. There's client libraries written for all the major languages, WSGI middleware, rack middleware, all those things. Homes is a mobile detection library that doesn't work very well, so don't use that. I've put, I've got a little bit of code in some open source frameworks. I've also got code in the Postmark PHP, CodeIgniter wrappers, Stripe PHP wrapper, Pusher PHP library, other jQuery things. Very nice. A lot of fun. Open source stuff. So, first of all, your web applications probably do a lot of things. Make DB calls. They do some sort of session handling, most likely. Image processing, perhaps, if that's the kind of application you do. They probably make API calls to third parties. Might be storing some analytics, sending email, you know all this stuff, showing forms, HTML formatting, form validation, you know all these things. Templating, caching, building reports. You might have an internal API of some sort that you're calling. You might friend people. Whoa, what's happened? Check into places if you're Foursquare. A lot of these things are slow and they break all the time, and that's fine. Most of them break. We do way too much stuff as web developers in line, in the user request lifecycle. It's too much going on, and that's not okay. So a major example, image processing. You probably heard Phil briefly talk yesterday about the company he works for, Capture. Basically, you take a picture with your phone, you send it up to Capture, you resize it, maybe make a couple of different sizes, make a thumbnail, got to watermark it, send that up to S3. In some cases, according to Phil, this could take a minute or more, and the user is waiting for all of this. It's not okay. There's things that break. There's API calls. You might be calling a third party. You might be making a request to an API that you don't own. Nothing you can do about it. That could break. Your user has to wait for this. Your application has to have additional logic to handle breaking this. It's kind of a pain. Purchase workflows are another example of things that break. I'm sure some of us, all of us, most of us have at some point had to work on a shopping cart of some sort. You have to authorize a credit card, make sure it's a valid credit card. You have to make sure that it's not stolen, do some fraud detection, all sorts of things there. It takes a bit. Sometimes you call a third-party API there to do some fraud checking against the last four of the credit card and IP address and whatnot. You got to do that. You have to ensure that the product is still available. Maybe somebody else logged in and bought the last one. You have to ensure you're charging the correct amount. You have to check to make sure that the number of products in the cart, there's no session handling, all that. Do a little bit of math. And then finally, when you're sure everything's okay, you actually charge against the card. Most of the time, the user is waiting for all of these things to happen. Sending emails breaks all the time. Again, you have the third-party API. Maybe you're using Postmark or SendGrid or SailThrough, something. Send a request off to them. They send your email. User is waiting for this. It could take a long time. It can break, even if you're doing it internally and just using SendMail or the new Laravel 4 mail system. It's shelling out basically to the OS. The OS is sending an email. It takes a bit of time. Your user's waiting for this. All of this stuff can be done without the user having to wait for it. There's no reason why your user should wait for this stuff. Things that suck or are possibly bug prone. Just a couple of quick examples. SOAP interfaces, other people's code. Perhaps you have a legacy system in place. An old code base, something else that you still have some methods in there you need to call. Perhaps bug prone. Or you have to deal with other people's code because your code doesn't have bugs, but other people's code does have bugs because you're well unit tested, of course, as you learned yesterday from Jeff. These are things that can take time, they can break, slow down the entire web request cycle. It's not fun. Some things are just expensive. When you do expensive calculations or any kind of expensive process or calculation, you're affecting all of your users, not the one user that's doing the expensive calculation, because your load is going to increase on your server. You're just going to have an all-around bad time if you start doing multiple of these expensive calculations. It's not going to be fun. It's going to be bad. The load's going to rise. The server's going to go down. You don't know why. You probably assume AWS went down, but that's not what happened. And a really expensive operation in web applications is deleting things. It seems like you should just say, delete from this table where ID is this. But a lot of times when you're dealing with more complex data model, there's a lot more that's actually going on that's not just deleting a single row from a table. The complexity of the code that I'm about to show is from Forest. It was O(n) squared or worse. If you know big O notation. Excuse me. Oh, this looks horrible. Basically, this is the method that we called when you deleted a post on Forest. First thing we do is we set the time limit to 0 because we know it's going to take forever. We get a little bit of information about the current post. We find out if there is a current user that deleted this post, or perhaps it was done from a command line administrative, whatever. We record an audit log to see who did it, why, make sure that they did it for the right reason. Save the audit log. If you've ever used Forest, you know there's a system of promoted posts where you can basically pay a little money or use acorns, we call them, to put your post kind of at the top of the activity feeds. We had to check to see if man, this just looks awful. I'm sure you can see what's going on though. If the post was promoted, we're going to give the user the acorns back because we're very nice. We also need to delete all of the activity for the post. The way Forest worked was we had the activity streams, actually still works this way, I assume, that didn't actually query against the post table or didn't query against comment table or the likes table or anything like that. What we did is every time somebody did something, we wrote an activity record so we could very quickly find all the activities that were relevant for you. So we had to delete all of the necessary activities. This goes on and on and on. It's probably not that important. If it was a reply post, which was legacy from Forest 2, we delete all the replies. Remove activities. This goes on and on. Remove the likes, remove the flags, remove the comments. Comments have all of the same problems. For each comment, we have to delete the comment. That has the entirely same problem. You have to do all these similar types of things again. Remove the taggings. You could tag a post. We don't need that anymore. Fire up Redis, and then blow away all the caches for this particular post. This entire process took forever. It never stopped. And then if you were deleting a user, you had to do all this not only for a single post, but for all the users' posts and everything else. It just took forever. It's horrible. Another example, calculations. Oh, this is awful. At SeatGeek, we have something called Deal Score to basically expose a great deal for a ticket or, well, actually just a ticket. We try and show you not based on price, but based on quality of the seat. I don't know why that's flashing.
That's cool, I like it.
Yeah, it's a feature. I'm just going to make that go away. There's a lot of calculations that are done every time the page is loaded to calculate those deal scores for tens of thousands of tickets that we scrape for each event, each page load. Can't do these calculations in line. A lot of things we do, we put in our API. Our API exposes listing count, how many tickets we currently have available, the average price of a ticket, the lowest price, the highest price. There's more metrics that we use internally that we don't expose in the API. Every single time an event page is loaded where you see the map with the ticket listings on the side, all these calculations have to run. If we did this in line, it would take ages, minutes. And we can't let the user wait for that. The user is going to leave, they're going to go away, they're going to find somewhere else to buy a ticket because the page has taken 3 minutes to load or even 10 seconds, and that's too long, and they assume the site's broken, move on, they do something else. Example of an API request here for a Justin Bieber show playing in Washington, D.C., where we are. You can see we've got currently about 5,500 tickets, $200 average price, so on. Highest price, $5,000, seems excessive. But we have to calculate these every time. There's other expensive operations that we all do. We make backups of things. You can download your entire Twitter archive. You can build reports for, your marketing or your accounting department needs reports all the time. They always want more reports. We do analytics, all these things that crunch data that needs to actually happen with every web request, but we don't have time to do all these things. So what do we do about this? What do we do about these problems? We use background jobs. Goes off a bit, but it says background. So quickly, the basics of background jobs and queue servers and background job servers and message queues is this. I drew this yesterday. You've got an idea of a producer. The producer is basically going to put things into your queue. This is usually your application. It could be anything. It could be cron jobs. It could be API request, anything. But basically, you're going to have something put a message into this queue of some sort. The queue server is responsible for holding on to these and very little more. Some queue servers, which I'll talk about in a few slides, have more features, more extendable, scale harder, better, faster, stronger. Then you've got these workers. You fire up these workers. They can be in any language, Python, PHP, Ruby, JavaScript, whatever you like. They ask the queue for some sort of job. They see if the queue has a job available. If it does, the worker is going to process this message from the queue. The queue should also probably be responsible for locking these jobs once they've been requested by a worker so that you don't have two workers running the same job. You don't want to send the same email 15 times to the user because 15 workers listening to the queue all said, oh, great, I need to send an email. And then they send the email, and then it's a mess because you've sent out a lot of emails. That's no fun. So some quick vocabulary on the thing, on the subject. This is all, actually, the vocabulary is based on Beanstalk, which is a queue I'll talk about in a little bit. It's my personal favorite. But the concepts are the same across all of the queues. You've got priority. Is one job more important than another? Charging a credit card is probably more important than sending out a password reset email. Ready. Is a job ready? Has it been put in the queue and it's waiting for a worker to pick it up? Is a job reserved? This is basically the locking that we talked about just a second ago. Is this job ready to be, or is the job taken by a worker? Is the job delayed? Did it crash? Was an exception thrown? Probably. Throw it back on the queue, give it a timeout. Maybe the third-party API will work itself out. Maybe not. Beanstalk and all the other queues, major queues, have a concept of tubes, which is a channel of sorts, where you can put a job into a specific channel. You can have a worker listen to only the specific channel. So you can be extremely modular about your background jobs. And then buried, it's crashed 10 times. It's not going to fix itself. Throw it at the bottom of the queue. Don't worry about it. Fix it later. Read your exceptional or your air break emails and see why it broke. It's broken. It's not getting fixed. We'll keep track of it, but don't try and run it again because it's pointless. So the anatomy of the flow is very simple. You've got the producer. It should have a very simple API. It should be relatively light, asynchronous if possible, not required. Should lock, the multiple email problems I said before. So typo. Queue is the meat. It's the central part of this entire system. Should be locking. Maybe in charge of distributing if your queue is if you're trying to scale across multiple servers or whatnot. Again, I'll touch on that in just a minute. And then you've got the workers that reserve the jobs from the queue. They need God or supervisor or some other persistent or process to persist these things in case they crash, run out of memory, whatever it is. They need to, if they crash, fire them back up. Excuse me. So, queues, lots of them. Probably most people have, in this room, have MySQL, Postgres, some kind of typical relational store that they're using. Seems like, oh, this might be a good idea. I can just throw a request into a MySQL table, run a cron job every hour to pick out these things. Seems like a good idea. It's not a bad idea. It's not a great idea. Excuse me. It's okay. Pros of using MySQL. It's built in. We've all got it. And there's no barrier to entry. You can simply create a table that says jobs. You write to this table. You have workers that read from this table. Seems simple. It is. The cons. It can potentially slow down your application if you have a lot of workers trying to read from this table. And it's also sort of hard to solve the locking problem for several reasons. You need to know which worker has reserved this job. You also need to make sure that some worker does have this job. Making all these SQL queries like the workers are going to do is going to slow you down a lot, and your slow query log is just going to fill right up because you're now reading from this table a lot. And there are definitely better tools for this job. So maybe Redis. Redis is a great tool. A lot of us, maybe, I hope, some of us are using Redis in some capacity in our applications. If you're not, it's an amazing key value store. It's very fast. Sort of clusters, but not that well. It's got this concept of lists. You can push something to a list, pop something off of the list. Great. So now you've got this locking problem solved. It's hot. It's new. Everybody loves Redis. It's great. I hope you all love Redis very much. It's extremely fast. The API, there's nothing to it. You push something onto a list, you pop it off. It should be free because you should be using Redis somewhere in your app. Use Redis. It's one of the few tools that I really, really enjoy using. Cons, it's not always free. You might not have it installed. And Redis persistence is always an issue. Redis saves based on number of keys written in time span. You know, if 500 keys have been written in the last minute, save. If 1,000 keys have been written in the last second, save, whatever. It's all configurable. But almost always, if your Redis server goes down, you're going to lose a bit of data. It's not a persistent store. Again, there are better tools. Maybe Redis PubSub seems like a great idea, which it is. Any of you familiar with PubSub and how that works? Redis PubSub, a few of you. So it's basically a message queue where you can send out a message and you can have multiple different listeners listening to it. So you can say, use SeatGeek as an example. Someone loads an event page, you say the statistics change. I've got 10 parts of my application that are interested in knowing that the statistics for this event changed. This works with none of the subscription side of the publish subscription side is going to lock. It's just going to be the messengers out there. Anybody that wants to listen, listen. If you don't want to listen, ignore it. Carry on. It's a very cool system. It's extremely fast. It's definitely more of a message queue, which is slightly outside of the scope of this talk, though questions encouraged. Pros, multiple listeners, easy API, should be free because you should be using Redis. Cons, there's no persistence at all with PubSub at all. You throw a message into the vast. If something's listening, it'll hear it. If nothing's listening, the message just goes away. You never see it again. There's no storage, nothing like that. And because of this piping to dev null that you're sort of doing, it's sort of hard to debug, especially across multiple environments, multiple servers. Why didn't my client receive this message? I don't know, because the message is gone. It's a bit tricky. It's no problem. Better tools. The real queues, the actual queue servers that are available to pip install or whatever it is, the elephant in the room, RabbitMQ. It does everything. It does all of the things. It's a great queue. I don't have a cute all of the things guy, but picture it there. Pros, it's popular. This is a good thing because the community is bigger. Nothing else to it. It's not my particular favorite tool, but it is popular, and if you do need help, you can get it relatively easily. Documentation is reasonable. It has great persistence using SQL or Redis or any kind of data store. There's lots of different brokers and shippers and things which are, again, outside of the scope of this. But if you want RabbitMQ to store all your jobs so you can later see how many of your jobs failed over a time span, you can absolutely do that with RabbitMQ. It has kind of fan-out distribution, which is similar to PubSub, but with persistence. So that's really cool. Scales really well. Uses a Zen-like sort of rabbit discovery. So you just kind of fire up a bunch of them on different servers and they find each other, which is really nice. However, not all is great in RabbitMQ world. There is an insane amount of configuration. Rabbit is written in Erlang, so you need Erlang, which is not a problem because Erlang is a great language. But if you don't already have it, it's just another thing you have to maintain. Also, operations can become an issue. If a cluster goes down or a node goes down, you might have a hard time quite figuring out where your jobs are going. It's kind of has a weird failover situation. And it's a lot of more boilerplate code in your producers and your workers to actually push something onto Rabbit for the most part, not always. But doing some of the more complex things that it offers requires a lot of boilerplate. Gearman, great choice. Another message queue. I have very little experience with this, and I got these points from Phil on the bus here. According to him, it's very simple, single channel, lots of client libraries, and you can persist optionally, again, with MySQL or Redis. Great. Persistence is good. Cons requires MySQL or Redis for persistence. Again, if you don't have one of those things in your current application, it's just another moving piece. Something else that can break, something else that can go wrong, something else that causes trouble for the user, which is what we're trying to avoid in the first place, right? Also needs a PHP extension, so you have to do a little more ops, edit your PHP INI file, throw the thing in there, install it. It's not horrible, but it's a bit tough. But it works really well. It's a great option. Another option, Rescue. Rescue is fantastic. It has a really great built-in dashboard. The whole thing is built on Redis and sort of installs itself, so if you don't have Redis, it's not that much of an issue. It's extremely fast. Jobs are processed very, very quickly. It's easy to spin up multiple workers. It's always persistent. Footnote, as long as you have your Redis backing up things, reasonable time. Cons, requires Redis, sort of. It's relatively Ruby specific. There are client libraries written in other languages that you can interface, but it is relatively Ruby specific. You can write jobs in PHP and push them onto Rescue, and they work, and that's fine. It's written in Ruby, which is not a con in itself. Ruby is a great little language. The biggest problem I find with Rescue is that everyone's forked it. There's PyRescue, PHP Rescue, Erlang Rescue, Go Rescue, all these other things. There's no real centralized code base. Everybody's trying to solve the same problem again in their specific language, even though it's probably fine in the language that it's written in. So I find that to be a bit of a problem. Another good, reasonable option. Beanstalk. This is my favorite. Nothing to it. It's very simple. It's got multiple tubes. It's intuitive. And it has one job. There's almost no documentation because it doesn't need any. You put something on the queue, you take something off the queue. That's all there is to it. Cons, there's no dashboard built in, which is a bit of a con. There's no persistence natively. Good, reasonable option. I'm pretty sure that was just copy and pasted from all of the previous ones. Some more advanced topics that I want to touch on briefly, such as scaling with multiple workers and scaling with multiple servers. In all of these cases, you can have a single worker that sends email, and it listens and waits to get an email, runs through its script, sends the email. That's great. If you have thousands of emails to send, you can have thousands of workers running, theoretically. You can also scale across multiple servers, so you can make you can scale the queue servers across multiple servers so that you don't bear too much load on any single server. Another point of failure, another thing that we just want to avoid, anything that could possibly take your site down, anything that could possibly make a user wait longer than he should, can be solved with one of these two options. A couple of best practices. The message that you actually put in the job from your producer into the queue should be as small as possible. You don't want to send information that you don't need into the queue. A small JSON blob with perhaps a primary key of whatever you're working with. Your job should be specific enough to where it's called send order submitted email, for example. All you need to do is send across the ID of the order, and the worker should be responsible for the rest. You don't want to send a lot of information, a lot of context into the queue. It's not necessary. It slows things down. You just don't need it. Also, it should be JSON and not serialized PHP, which is what Taylor's done in the queue, but he's going to fix it. Because this should be a language agnostic process. You shouldn't have to read from the queue in the same language you put it into the queue. This is a tiny little block of code from the new queue implementation in Laravel 4, which is very, very, very nice. Where you pass in a job and some data, and it sends it on. Serializes it, should be JSON. It's fine. I got a pull request in. So I have a couple of examples just to sort of show you how this works. I'll show you a small bit of code, and then we'll run through a little bit of it and see how it works. And then after the examples are done, do a bit of Q&A. Sound good? Everybody all right with that? Perfect. Nope. Another tab. So I've got a few things here. Let me find a terminal also. Oh, it's huge. So I've got, whoa, I want to print my terminal. Does that make sense? One tab, I've got Beanstalk running. Brew install Beanstalk on your local machine. Similar process if you want to chef it up or whatever it is. You just sort of go on about that. No problem. Here I've got the artisan queue listen, which is specific to Laravel, which will listen to any messages on the queue. I've already sort of configured it. There's just a couple of lines you change in the configuration to tell it what queue you want to use. I got a couple of Python workers here that we'll fire up in a bit. So we've got this wonderful Laravel app that creates a user, updates a user in the background, updates it with Python, updates multiple users at once. Nothing to it. However, the one line of code that all of these methods have in common is this slow process, which sleeps for 20 seconds before it does anything. Sets the updated status to true, saves it. That's all it does. But it's slow. The user has to wait for it. So a quick example, you do this in line. I'm actually going to do this. You do it in line and you wait. And you wait. And you keep waiting. And it takes 20 seconds. And we're going to wait through the whole thing, as painful as it is. This is what your users are saying when you're sending an email or you're charging a credit card. keeps going. I probably should have done like 10 seconds. Oh, there it is. It's done. The user in that time didn't know if their click worked. It didn't know if their credit card got charged. Maybe it got charged twice. Maybe it sent their password reset email. Maybe it didn't. They don't know. So we have another job. I wrote a simple worker. The only required method in a Laravel worker is fire. This is the method that gets called when Laravel finds a job. It takes a job object, which is its representation in the queue. It could be IronMQ, which is a cloud-based thing. SQS is also cloud-based, or it could be any of the queues I just talked about. It listens. It runs this method when it finds it. So you've got a couple of methods here that you interface with. Delete is probably the most important, which removes it from the queue, says it's processed, carries on. Go back a bit. The first method I called, update user, runs the slow process inline. This next one, for my sanity, set updated to 0, which probably should be false. Saves the user, and then uses the Laravel API queue, push, update user is the class you're going to call, and then your data, which is, in this case, a primary key. The ID is 2. That's my user. And then we return a view. Let's run that one. Fire up our worker. Sits there. Oh, now we've got the page instantly. There's just a little bit of a JavaScript here, constantly polling to see if the job is finished. It checks the column in the database to see if it's the updated has been changed from 0 to true. This could be image manipulation. This could be saying all the things. Much less painless. It's less painful. And that's updated. No pain. None of the pain. Now it's updated. You can see it's updated. The user got to read their boilerplate text while they were waiting for their job to finish. They knew it was going on. They had some more feedback. That's great. However, it still took 20 seconds. Perhaps it could be optimized to take less than 20 seconds in a different language or on a different machine. So after doing some code review, you realize, oh, maybe Python is better suited for manipulating this image. Interface is exactly the same. We have another route, finds the same user, does the exact same thing. It listens on a different tube. The push API takes an additional parameter, which is a tube that you can listen to, which we also briefly talked about earlier. For my sanity earlier, I just called this one Python, but it's not required. It uses the default tube by default. Regardless, kill the PHP worker, fire up our Python worker, which does the exact same thing. Connects to Beanstalk, watches the Python tube, connects to SQL, and then it has a while loop. Turns out the 20-second task in PHP only takes 8 seconds in Python, which, yeah. So let's go back. Let's try this again, background in Python. User gets the page instantly as the same. Hopefully they get updated in 8 seconds. That's a lot better than the 20 seconds. So now you're realizing maybe we should be able to refactor our code into multiple different languages instead of being so reliant on one. Image resizing is a great example. Python is really, really good at it. And the pill library is really, really nice. And all we've done here is not change any of our application code except for a configuration. We just run a worker in a different language. Now it's faster. And that's great, because now the user isn't waiting at all. The other thing that can happen, you need multiple workers, because you're not just updating one user, you're updating hundreds of users. Or, in the case of this example, 30 or 40. It does the same thing. It runs the exact same line of code in the application. We queue up these jobs. There's a little Beanstalk console that'll show us if there's jobs queued up. Maybe. Maybe not. Great. You can see 44 jobs are ready. There was a total of 60. One's reserved. So we have one Python worker. Still takes 8 seconds. But what we can do is fire up more of these workers. Each one is going to grab a single object, do its processing. And this should update live. You can see as the Python workers, there's three jobs reserved at any time because there's 3 workers running. You can see the ready jobs drop 8 seconds at a time, or probably less. Total jobs you process. This is just a Beanstalk console that's not built in, but you can get you can clone it down from GitHub. It's for free. See some other things here that are a little more advanced that I wasn't touching on, which is the pausing, the exception handling, throwing things back onto the queue, other things of that nature. And that's it. Questions? Yeah, sure. Yeah. Mm-hmm. So race conditions are hard. Using a good queue, Beanstalk is really good at it. MySQL is really bad at it because write times are significant. It does happen, can happen. Using a reasonable queue and reasonable coding methods, it shouldn't happen. But it's definitely possible. Yeah.
Have you looked at something like Celery, which does actually all the management for the queue?
Yeah, so we used to use Celery at SeatGeek, and we got rid of it because the ops was just such a pain, and it was a pain. Yeah. It requires brokers, it requires shippers, it requires a whole lot of components that just kind of make the whole thing a mess. Yes, it does do a lot of the management for you in the same vein as Rescue or some of the other things. It just, to me, is a bit complex for doing something as simple as doing something later. Yeah.
Do you have any like novel uses that could be used on common sites where I have an everyday web app, some interesting ways that you might use queues?
Yeah, so send all of your emails in a queue, no question, for one. Because almost certainly you're sending an email, use a queue. There's no question. That stuff breaks, it's slow. Yeah, anytime you're integrating with Facebook or Twitter APIs especially, because they're notoriously dog slow. Do it later, make an AJAX request to see if it's finished, show the user their friends in a bit, or pop up some kind of notification bar at the top or whatever.
Also, anytime you have to do one thing at a time, for the queue, could you use one worker?
Yeah, if you want to do one thing at a time, use one worker.
I got an example for you too, which is at Snappy, we're going to use the queue when somebody signs up. We're going to send them in emails over the first 5 minutes to so they can see the interface change. So it's going to load up a bunch of emails in the queue, and then 30 seconds an email shows up, a minute and a half email shows up, 5 minutes email shows up. So they can see the system work without having to put in a bunch of fake data and stuff.
Yeah, it's a fantastic use of a queue.
Thank you.
What's that? Sorry.
I use something similar to send to Apple's push notifications.
Yeah, another great example. Something that's not important that can break and it won't completely ruin the user experience or even slightly degrade the user experience is fine. As long as they're not waiting. They know something's going on. They're not quite sure what.
How are you organizing your queue?
We use both God and supervisor, depending on if it's written in Ruby, we use God. Otherwise, supervisor. Supervisor D. Yeah.
Yeah, but can you go over maybe some examples of when you get errors and how you sort of go over?
Error handling examples.
Yeah, so it's incredibly strong.
Hello.
Yeah, so in Beanstalk, which I'll just continue to use as the kind of floor example, you can do any kind of error exception handling in your code that you would normally write in your code. so perhaps this could throw an exception, whatever. There is a job kick, I believe it is, in Beanstalk. That might not be correct. Basically throws it back onto the queue with a lower priority. And you can also keep track in your worker how many times a specific job ran. Do we want to give up at some point? Some queues definitely do a better job of this. Rabbit does it by default. It's going to try 3 times. If it throws an exception, throws it back on the queue. Oh, I've already thrown this exception 3 times for this specific job. Done with it. Send an email.
Laravel handles a lot of that automatically, though. Too. Like if you were to throw an exception in that method, it would automatically release it back onto the queue, like a delay that you can specify. Also, the way it passes job is the first parameter. You can call job attempts and get the number of attempts you've had on that particular job. So you can say like if job attempts greater than 5, like job buried or something like that. So, but if any exceptions are thrown, those are caught for you and automatically the job's put back on. So.
Awesome.
What
Kenny?
happens if you need to give the user feedback about a specific error, like if you're charging a credit card and then you find out that
User feedback.
Yeah, so all of this logic can be handled in your worker. Either with processing a credit card, probably makes sense to send an email. Send them some sort of confirmation, or we're processing your payment email. Try all of the things. If something doesn't work, fire off an email that says something didn't work, try again. Is the case I've used the most. Or you can have something polling for a table that's looking for error messages or whatnot, long polling WebSockets, whatever it is. Does that answer your question? We can talk about it. Yeah.
I guess it kind of expands on his, but I guess like chaining the queues up. Like when a worker takes a task and it
Mhm.
does its thing, can it send back to the queue to put in something else?
Sure. Yeah. I mean, it's there would be no reason why I can't in here do queue push. I can't spell, but if I could, different job and then the payload. I'm not good at this.
Would that be a scenario where, let's say you're deleting a user and you have to delete their comments in
Mhm.
the post, so you would just put all those queue push like just right in there?
Yeah. So the way the forest deleting a user with the multiple posts worked was not very intuitive. It sort of created a job that created n jobs, where n was number of posts, and the same thing for comments and whatnot. So basically, user clicks delete, and instead of creating one long running job, it created 200 shorter running jobs. But yeah, I mean, it's followed this pattern in some capacity, where you just push from the.
Using multiple languages, like if one job requires another job to run, it's like a bit of PHP to kick off a bit of Java. That would be a perfect example to do that.
Yeah. There's too many hands. I can't pick. Somebody start talking. You.
You mentioned that the queue and the producer should lock.
No. The producer shouldn't lock.
Oh, okay.
My bad.
Okay.
Yeah. I would ask Taylor.
Laravel events on the queue.
Laravel never puts anything on the queue like out of the box. Is that what you mean?
Or firing events.
Yeah, Laravel doesn't touch the queue ever. I mean, you have to add any queue push if you want. So I don't know. I may not still be understanding that.
If something's added to the queue as a priority.
Oh, no, not right now. No, there's no job push within or anything like that.
Yeah.
How many of the queues allow you to like schedule events like in prompt? So something, say a user signs up and say, I want to send them a how are you doing type email 24 hours from now.
Okay. Yeah. So there's a queue later method which does that. That's awesome. I feel like the better actually solution is to actually write a cron job that kicks off a queue, pushes something to the queue an hour later. Select all users that signed up today, fire off a job for each one of them after the fact. Though that would also work. You can also delay these jobs with queue later. Yeah, Sean.
What's the distinction set to a huge delay?
So if you're using one of the queues that doesn't persist, that's a problem. Um, I try and keep things as simple as I possibly can. And the setting a something with an extremely long TTL or whatever it is can sometimes be hard to debug, where I can fire off the cron task manually from the command line without having to worry about it. Yeah, I think it might clean things up a little bit and give you kind of more readability, though it's not a bad solution to queue something up for 24 hours later. But if your queue server goes down in that time period, or you lose your Redis connection or whatever it is, you're going to have a problem. Yeah.
You got much experience with dynamically scaling the number of workers?
No.
No.
None. Yes. I mean, not dynamically scaling number of workers. As with anything in, web programming or programming in general, fine-tuning things is a very black art. It's very hard to do to get things just quite right. If we find some load is high on a box, we see that there's 40 Python processes working too hard, we spin up a new box. It's kind of manual at this point. But
We use AWS CloudWatch for that as well. So the server starts, you can set certain alarms and triggers. So if a certain box gets like crazy loaded, you just fire up on the box and it'll register itself with the queue and do the same thing.
yeah.
How would you handle say you were firing your job to refresh something in the cache, in between the time the job finishes and that cache is actually put back, you could have more than one person hits it, you could get the job queue 3 or 4 times, right?
Yeah. So
I don't know. I've seen some approaches, but I don't know if you had some.
so they say there's 2 hard problems in computer science: naming things, cache invalidation, and off by 1 errors. And you just described one perfectly. It's a hard problem. The one thing you could do to sort of solve that problem is, before you kick off the job, mark it as mark your post or whatever it is as just disabled, and kind of write queries to not include certain things. But yeah, I mean, it's definitely a problem. You might still have some cache left over. Your job should run relatively fast, especially if they're doing something like that, to kind of get out of the way. Anybody else? Nope. Good.